Welcome to Orensha Tech's PowerShell series. In this video, we're going to go over background jobs, which in the context of PowerShell is taking a command and pushing it into the background somewhere, whether that is locally on your computer or on a remote computer. So be sure to check out the previous video on remoting to make sure that you're familiar with how remoting works and how to get that set up on your computer. Now, background jobs on your local computer is simply taking a command and pushing that either to a separate thread or a new process entirely to run that command, and then you can retrieve those results at a later time. But this means that you can keep using the shell in the meantime while that background job is running. Now, the same thing applies to remote computers, but you're actually offloading the processing power of those jobs as well. So this means that you could take resource intense queries and split them between multiple computers and then go retrieve those results from your computer without having to put all of that processing onto your local computer. So this is a super awesome technique and definitely one to put into your toolkit. So let's break down command workflow and the two types of command running that you can do. The first is synchronous and the second is asynchronous. Now, synchronous is simply running a command and waiting for it to finish and give you the results. But asynchronous is taking that command and pushing it into a background job. So let's go over the major differences between these two different ways of running commands. When it comes to input requests for your commands, synchronous is going to allow this, but asynchronous will fail because you're not there to manage the command workflow. So user input is going to fail on background jobs. With errors, synchronous is going to immediately show you these errors. Asynchronous is still going to capture the errors, but you'll need to go and retrieve them later. And there's definitely a whole subtopic we can go into for error management, and I will make a video for this later. For required parameters on a command, synchronous will prompt for you to enter those. However, asynchronous will fail. So you'll need to make sure you get all your required parameters in the command before you push it to your background job. Now with results, synchronous is going to automatically show you them as soon as it's done. Results run using asynchronous commands will need to be retrieved later, which ultimately could be a beneficial thing. So understanding the difference between these two types of command workflows is going to give you a broader spectrum in which to work in PowerShell. And a great way to look at the methodologies between synchronous and asynchronous is that synchronous is great for testing and getting your scripts working, making sure that there's no errors, getting all that debugging done. And then once you've got that complete, you can take your commands and your scripts and use them in an asynchronous fashion. You can push your scripts to another computer and retrieve the results at a later time. And the last thing I'll note before we jump into background jobs is that jobs apply to a broader scope than just background jobs. You can potentially create a lot of different types of jobs, but in this video, we're specifically focusing on background jobs. Now let's jump into what it takes to create a job and the different types of jobs that you can create. The first that we'll go over is called a process job. And this is simply telling PowerShell to spin up an entirely new process of PowerShell in which to run your background job. And the command to do this is start job. So let's look up the help for this. Some of the key parameters to be aware of for this are going to be script block, and this is going to be where you put your command that you want to run in your background job. Another parameter that is commonly used is the name parameter, so that you can give your background job a name. Now, PowerShell is just going to automatically use their default schema for naming if you don't specify anything, which is just job 1, job 2. But something to notate is that each job is going to have child jobs. So the job ordering is going to look a little bit wonky. It's not going to go exactly 1, 2, 3 for the initial background jobs that you're running. So just something to be aware of. And another great parameter is the file path. So you can actually store your script in a file, and then using the file path parameter, you can just specify that you want to take the script in that file and run it in your background job. And then one last parameter that I'll notate here is the working directory. So this is where you specify where you want your commands to start out. The default is the home directory for that user, but it is definitely something you want to be very familiar with where your commands start out. So you can always change where that is using the working directory parameter. And before I show you an example of this command, I want to point out that you do need to have remoting enabled on your local computer to use the start job commandlet, because it is essentially just mimicking how we run jobs remotely on other computers. It's just doing it on your own computer by spinning up that new process. So again, check out my other video on setting up remoting so that you can use this command. So if we want to start a job, we'll use our start job commandlet with the script block of get process. So you can see there, our job name is 6. The PS job type name is background job. You can see the state is running and the location is localhost. And it even tells you the command that you run in your script block. And then this too here, the ID, so that you can specify your jobs based on a unique ID. And before we get into retrieving these jobs, I'm going to go forward and show you a different type of job that you can run. So that first one there is creating a new process, but there's a different type of job that simply creates a new thread in the current process of your PowerShell application. Now, since it is just spinning up a new thread, it is much quicker to use this type of background job. So it's great for short-term scripts, but you are going to run into issues where if you push too many thread jobs at once, it's going to start slowing down. So there is a parameter called throttle limit, and the default for that is 10. So essentially you can run 10 thread jobs simultaneously before it throttles you, but using that throttle limit parameter, you can increase that number. But again, you're not going to see a great return once you go past the 10 limit. Otherwise, the parameters are very much the same as our start job commandlet. And the main command for this is start thread job. So start job is process, start thread job is for our thread jobs. And we'll run something very similar here with our script block parameter and get process. So you can see in our PS job type name, it does call out that this is a thread job. And interestingly, we can see that it's in a not started state. Now we'll go over the details of this next command in a little bit, but we can use the get job commandlet to show us the results of those two jobs that we just ran. So we can see that our thread job completed already, which points to that notion that thread jobs are much quicker to spin up. And our background job is still running. So definitely something interesting between those two different types of jobs. But before we get into the semantics of get job, let's go over running remote jobs on other computers. Now, this does require PowerShell version 6 or higher, unlike the other two that I just showed you, the process job and the thread job. Now, running remote jobs is effectively like running a process job because it is just creating a new process. It's just on another computer. And I want to notate again that this gives you the benefit of offloading the processing power away from your computer. So if you have some beefy queries, you can just push that to another computer, perhaps one that has a lot more power, or just something that you want to push there and forget about while you do your work on your local computer, there is a great benefit to having this type of tool in your toolkit. So the command for these remote jobs is going to be Invoke-Command, and we'll run the help on this, but the parameters are going to be pretty much the same as our start job and thread job. We're just going to have a lot more parameters around the concept of our remote computer. So things like host name and computer name. But again, I did go over all of those in detail in my last video, so I won't spend a great amount of time here describing those parameters. So let's run an example of this command. So let's break down this command piece by piece. So we use the Invoke-Command commandlet with our script block parameter to specify the command that we wanted to run, and our computer name to specify which computer. And again, remember that computer name is using Windows Remote Management, and host name is going to be using SSH. So we've got our Windows machine here. So we're using Windows Remote Management, and then we specified our credential, and then we're using the as job parameter. And this is the key to turning a remote command into a background job. And then we can just use this job name parameter to give our job a name. Otherwise, it would have been along that default naming convention. But as you can see here, we've got our job. It's running, and we can retrieve the results of that at a later time. And before we move on to retrieving those results, I just want to call out this parameter right here. So you're going to want to look out for this parameter on different types of commandlets, especially in the Azure suite of commandlets. You're going to see this parameter to turn your commandlets into jobs so that you can push them to the background and get the results later. And that way you can keep working in your shell in the meantime. So while you're perusing the help for your commandlets and learning about them, definitely always make a note when you see this as job parameter so that you can catalog that as a command that you can always push to the background and keep working in the shell. So let's go over getting the results of our jobs. The commandlet for this is going to be receive job. And there's going to be a few parameters here to help us specify which job we want to receive. So here we've got the job, and that would be used in the instance where we use the get job commandlet and piped it into the receive job to give us the results of all the jobs that we have. Or we can break down the get job to filter on a specific job. Here we have the computer name to specify receiving the jobs from a specific computer. And then another parameter I want to point out is the keep. So if you don't specify this, after you receive the results of your job, it's automatically going to get rid of them unless you specify this keep parameter to keep those results and the job cached in your background job results. So if we hop down here to, you can see we have the ID. So if you remember, we did have unique IDs for all of our jobs. So you can use this to specify exactly which job that you want to receive. And before we run this command, I do want to point out that the results that you receive may be deserialized objects. So the results that you may be seeing might not be the active working objects for that computer. And this is especially the case on those remote jobs. So let's look at using this command, and we will use the ID parameter to specify a specific job. We've got receive job ID, and we'll go with 8. So here we receive the results of our thread job. We go up to the top, we can see that it piped the results into the standard out default methodology to display these in a table. But something really cool that we can do is always pipe the results further down to manipulate the data a little bit more. So let's grab the results from our remote job, and we'll use our get job commandlet to show us which ID that is. So we can see here that the ID on that is number 9. So we'll use receive job, ID 9 and pipe that into select object, and we'll use our first parameter to grab the first 3 and then pipe that into format list. And that took the results from our remote job and just grab 3 of those results, and then we can format that however we want. So we could even pipe that into a file somewhere or export it and convert it into CSV. So lots of things that we can do. Okay, next we're going to go over the concept of child jobs. I explained earlier that each job is going to have at least one child job. So we can look at those child jobs by grabbing our job and piping it into select object and expand on our child job property. So we took that first job that we created, and then it's just going to show us what the child job of that is. So it's just something to be familiar with and be aware of. It doesn't necessarily impact how you're running your jobs. It's just something to be familiar with, especially with your default naming and your IDs, how they're going to skip around because of the child jobs that are created for each of our jobs. And then some of the other jobs that we have are remove job, stop job, and wait job. And with wait job, this actually allows you to specify that you want to wait for a specific job to finish running before something continues, for instance, in your shell or in a script. So just a few more commands there to be aware of. And if you ever need help remembering any of the commands that have to do with jobs, you can always use your help and your wildcards to look for anything related to a job. This is going to pull up a lot of stuff, and you'll see here we've got Azure jobs, but it should help you look for all of the jobs that you need. So we've got debug job, receive job, remove job, start job, wait job. So if you ever forget, remember you can just use your help and your wildcards to search for anything to do with jobs, and you'll see them right there, and you can then go dive deeper by using the help on those specific commandlets. And before we end the video, I just want to go over some final thoughts. When we're running our remote commands, we should be aware that we shouldn't try to mix and match our start job and our invoke command commandlets. So we shouldn't do anything like this, where we're taking our script block and then putting a start job in there. We are essentially already creating a background job by using the invoke command, and that is what this as job parameter is used for. So we don't want to put a job creation commandlet such as start job or start thread job into an invoke command. It's redundant, and we also shouldn't be doing a start job and putting in our script block an invoke command, because these are just redundant and complicating things that don't need to be complicated. So just stay away from doing that, and keep in your mind you've got invoke command for your remote commands, and then start job and start thread job for jobs that you want to run locally on your own computer. And speaking of those jobs that you run remotely on other computers, or even the ones that you are running locally on your own computer, someone else, such as another user, isn't going to see exactly what types of jobs you're running within the process. The process may show that you are the one who initiated it, but it's not going to give you any of the details about the jobs that you're running. So if someone else sees that you started a process on the remote computer and you've got a background job in there, they're not going to be able to see what you are specifically running in that process. And then one last thing to be aware of is that jobs only last as long as your PowerShell session is open. So as soon as you close your PowerShell window, those jobs are going to go away. So it's a nice way that it cleans itself up, but also remember, if you close your window, you're not going to be able to come back and grab those results later. So either pipe those results into a file somewhere, or just expect that you're going to lose those results. And that wraps up this video on background jobs. I hope you found it interesting and learned some new things. Be on the lookout for my next video, which is going to go over managing objects in Bolt. But for now, Thanks for watching and have a good day.